All right, so this lecture will be on crude oil or petroleum. We're looking at a couple learning objectives. We're still in this enduring understanding of what energy sources we use, and they all have positive and negative consequences. We have some in this fuel types and uses learning objective or topic, and the fossil fuels topic. Here's the vocab, and let's just get right into it. So petroleum or crude oil is a fossil fuel. It's one of the three fossil fuels that we talk about: coal, oil, and natural gas. It is therefore going to be one of our non-renewable energy resources, just like coal and oil, just like what we talked about. They will be replenished over millions of years or geologic time just based off of natural processes. More algae and phytoplankton will die and create more oil, but that's not going to happen again for the next millions of years. So that doesn't really matter today. Okay, so non-renewable. And it's derived from the partial decay of organic matter, like I said, primarily plankton and algae. We have in crude oil various hydrocarbon chains. Those can vary from very short chains to very long chains. Those chains can branch, they can form rings or other complex shapes, but you guys don't really need to know any of the crude oil, like any of the distillate, any of the formulas of the distillates of crude oil, though we'll talk about the distillates in a general sense. And those distillates we refine for various products, everything from plastic production to fuel for aircraft to whatever. When we're talking about electricity production, we're talking about diesel or oil burning power plants. And a lot of this, the stuff that we're going to be using crude oil for is going to be transportation. However, what's not up here is that we can also get heat from it. We can use crude oil, not crude oil, but oil burning stoves. My neighbor, for instance, is a mechanic and he gets engine lubricating oil, like, engine oil, all the time as he changes people's oil. And he has a special furnace in his shop that uses that used oil, burns it, and produces heat for him. You can be refining off various products like propane off of crude oil and be using that for heat like in a propane stove. And when we're talking about power plants, crude oil is going to perform or provide consistent energy. And again, like you saw in the other PowerPoints on fossil fuels and anything else that combusts. Whenever you combust anything, you're going to be releasing carbon dioxide, and the carbon dioxide from petroleum or crude oil has been locked in the geology of the Earth for millions, tens of millions, or even hundreds of millions of years. Those carbon atoms, therefore, have not been in the atmosphere. They have not been bonded to oxygen to make carbon dioxide, and they have not been acting as a greenhouse gas for millions to tens of millions to even hundreds of millions of years. Now, how does crude oil form? You're going to have plankton living in the photic zone of the ocean. Those plankton are going to die, and plankton have a really fast generational lifespan. So you can have several generations of plankton just in one summer. Those plankton generation after generation, year after year, decade after decade, century after century are going to die and settle down to the ocean floor where they will partially decay. They will Most of the organic matter in them will not decay though, because it is very dark, cold, and anoxic water. So there's going to be little decomposition down there. They're going to get covered by more organic sediments, and they're going to get buried by inorganic sediments, sand, silts, clays, rock even. And as they get covered by layer sediment, they're going to harden into sedimentary rock, something like an oil shale, for example, and they're going to trap that organic remains, and that organic remains is going to turn into coal, or sorry, not coal, but oil and natural gas over geologic time. We can then dig them up and burn them. So how do we dig them up? Well, historically it was from onshore drilling or drilling just on the land, something like this oil well that you see in the top right. And as we went through the early 1900s, mid 1900s, late 1900s, we got the earliest and best supplies, like the purest, the easiest to get to, and the closest to the surface supplies of crude oil. We are moving on to, just like many mining operations, the more difficult to obtain resources. So the oil that is deeper, the oil that is locked in oil shales, for example, or tar sands. So we're going to these less conventional methods, and those less conventional methods include offshore drilling, where we do essentially the same thing on land, but out in the ocean. We have to take various precautions so that we don't release oil into the ocean when we do that. And we do hydraulic fracking and tar sands. As far as offshore drilling, you guys don't really need to know much of anything about it, except that it is drilling offshore, out in the ocean, whereas we're going to talk about tar sands and fracking. So first up, fracking. This is where we're going to inject fracking fluid, which is a mixture of water, sand, industrial secret chemicals, down into underground deposits of oil shale predominantly. And that oil shale has lots of oil in the tiny pores of that rock, and we're going to use this high pressure mixture to crack that rock, just like we talked about with natural gas. So we're going to crack that rock, and all of that oil and gas, natural gas, that is locked in those shales are going to start to move towards the surface, or at least be able to get into the well so that we can extract them. They have lots and lots of pressure of rock above them, and they are a liquid in the case of petroleum or crude oil, or a gas in the case of natural gas, and they therefore have a lower density than all the rock, all the solid material around them, and they're going to want to rise in that in that matrix, in that material. All right. So again, we pump this stuff down to the ground under very, very high pressure into the specific reserves that we want to, predominantly oil shale, and it will crack the rock and allow that oil to escape. This can result in unstable ground, such as minor earthquakes. So for example, Oklahoma has very little history of earthquakes, but then once they started to do widespread fracking around the state, earthquakes, minor earthquakes, I'm talking like, just little tremors, increased 100-fold. Okay. We have the potential to contaminate groundwater and surface water, air pollution, habitat destruction, and it's going to use a lot of water that has to be stored unless it's decontaminated. And from what I've seen, the industry prefers to store it rather than decontaminate it because it is cheaper to store it. So here's the same diagram that we saw in the natural gas PowerPoint. They will drill straight down until they get to the shale deposit that they want to, and then due to the way that the bore bit works, that well will start to be angled and then end up drilling horizontal into the oil shale. The oil shale is up here, and it is rock that contains lots and lots of tiny little pores that has lots and lots of oil in it. And you can literally make a campfire of that rock, which is kind of cool. You're going to inject down all of this water, sand, and chemicals into this rock under very high pressure, and it's going to crack that rock, and it's going to allow the gas, which is shown here, or the oil, to escape. And they're going to go from the crack into this opening and be extracted. Now you're going to be drilling this through groundwater. You're going to have to store the water that you're using as your fracking fluid on the surface, and all of this poses the risk for contamination of ground and surface water. The next unconventional oil source that we're going to talk about is tar sands, which is a little bit of a misnomer because it's neither tar nor oil. It's a mixture of sand, clay, water, and bitumen. And bitumen is not the same as bituminous coal, but it shares the same root word. It's a very dense, very viscous hydrocarbons, and it's think like kind of asphalt. Like it's super thick. It's kind of like very, very thick putty. Traditionally, what you would use it for is to make asphalt. You could use it to make asphalt roofing tiles, or more likely today, you're going to refine it into syn fuel or synthetic crude oil. It's a small portion of the US market, but it is increasing, though this is going to take a lot more energy to refine than traditional crude oil, and it's going to therefore release about 15% more CO2 than conventional crude oil during the refining process. As you might have picked up in the previous diagram, you can do some subsurface mining of tar sands, but most of it is surface mining. And this is an example of a surface mine for tar sands in the Athabasca oil sands or oil fields or tar fields. And these down here are these giant mining trucks, the giant dump trucks that they use for mining, the ones where the tires are like 10 feet tall. So this gives you a little bit of a scale of how big of an operation this is. This is an insanely massive operation. What we're looking at on the map on the right is not like one giant oil field and all of the Athabasca oil sands, but what we're looking at is several mines that are scattered throughout this area. And if you know anything about Canada, you know that there is a lot of water on the surface, whether that is rivers, lakes, ponds, whatever. And there is a huge potential for groundwater contamination, as well as obviously the habitat loss that you see here and all of the other negative effects that go along with oil, or sorry, with mining. And most of the tar sands that come from the Athabascan oil fields and some of the other fields in Alberta, Canada, are being sent to the United States for refining. Canada is definitely using them to refine their own fuels as well, but a lot of it is being sent to the United States for refining. And some of that, or a lot of it actually, is moving along the Keystone Pipeline. Now on the next slide, you'll see that there's a huge network of oil pipelines around the United States. So I just want to use this to illustrate a greater issue, just show one pipeline, and this can be extrapolated to many of the pipelines. Now, um, as far as I know, as of recording this video on February 12th, 2024, the Keystone Pipeline XL has paused. It was proposed to cut off the right angle of this triangle and make it more like a hypotenuse. So it's a little bit shorter of a distance than going all the way along this red dotted line that we see over here. To get this oil to either uh, Kansas or Illinois or Texas. Um, there have been several accidents, 22 recorded accidents along the Keystone pipeline system. And from a federal report that I was reviewing last week, they state that the spills have worsened over time, and a total of 1 million gallons have leaked. The worst one, December 2022 in northern Kansas on the border of Nebraska, where over half a million gallons of crude oil were leaked into Mill Creek. We'll see a picture on the next slide. Um, so yeah. So this image on the top right is the Kansas pipeline accident. So you see the creek right below, you see the pipeline probably somewhere right along here, and the burst from the pipeline that spewed oil all over this farmer's pasture, and then the oil that's dribbling into the creek. Um, and then you see the top 5 accidents on the Keystone Pipeline. This diagram says 23 accidents. The one that I saw when I made that last slide was 22, but I trust ABC News as a news source, so we'll use it. Either way, this is to illustrate a greater problem, which is the potential for pipelines across the United States to leak and the potential for pipelines across the world to leak, whether that is a pipeline going from the Russian steppes to China or across Saudi Arabia. Wherever it is, there is potentials for oil pipelines to leak. And like I said, the U.S. is crisscrossed by pipelines, especially in the Midwest and in Texas and the regions, the states bordering Texas in the south, like Oklahoma, as well as one that crosses basically the entire north-south range of Alaska from the Arctic, the oil fields in the Arctic, down to the southern coast. I believe that's by Anchorage, but I can't really tell on this small of a map. Anchorage, I think, is actually over here. That might be closer to Valdez. Anyway, so the leaks on the Keystone Pipeline can just be an indication of all of the potential for leaks along this entire, all of these miles of line. And if you want to, you can check out the website at the top right. It's kind of fun to zoom in and play around and see what pipelines are, coming around us in Denver, Colorado, or wherever you are, and just see where these pipelines are and do a little bit of research, see if there's been any leaks on them. It's kind of cool. All of these are going to go through habitat or farmland or both. A lot of them are going to go through urban areas. A lot of them are going to be parallel to rail cars or roads. So if there is a accident on a rail car that lights a fire, that has a potential to break a pipeline and then ignite oil. For ones that's going over mountains in Alaska, there's the potential for a leak out in the frozen depths of winter where they can't really repair it and it's just leaking crude oil that entire time until the next spring. So all of these can come with the potential for contamination of soil, water, or or any type of natural or agrarian habitat. All right, then once we get this crude oil and once we get it to a refinery and wherever it is, and however it gets there, that doesn't have to be by pipeline. It could be by ship. It could be by truck, very much less often. It could be by rail car. But however we get it to the refinery, we then refine this crude oil. So petroleum is not going to be something that you're just going to burn crude oil. You're going to distill it into its various products, and you're going to distill it based off of boiling point. So different hydrocarbons are going to have different boiling points, as you can see on the right. So like butanes and lighter, they're going to they're going to boil just at ambient room temperature. Naphtha is going to boil between 32 and 88 degrees Celsius. Heavy naphtha, 88 and 193. Kerosene is going to be 193 Celsius and 271 Celsius, etc. Going down through this chart, and this is definitely not an exhaustive list. It's just a sample of them. And we're going to use these different products for different things. So for example, refinery gases like these bottled gases, that could be methane, it could be propane. You're going to use it in butane, you're going to put in a lighter. You're going to put propane in a bottle and sell for somebody to use on their propane grill. Gasoline is going to boil off next according to this diagram, and it's going to be used for cars, obviously. Kerosene is aircraft fuel. Diesel has a heavier, longer chain hydrocarbons, lower boiling point, and it is going to be used for vehicles. Heavy fuel oil, burning off then, or next, and that's going to be used for ships and power plants. And then finally, the sludgy tar that remains is bitumen, and that's going to be the primary component of asphalt, and whether that's on roads or on roofing shingles. Okay, but there's many different byproducts of crude oil that we'll discuss on the next slide. Actually, even the next slide. So just another show of the fractional distillate of crude oil, all of the different products that you can get off of it. All right, and then once we refine off those byproducts and all of the other ones that we can refine from crude oil based off of boiling point, again, we can use those for various things. We can use them just to burn as a fuel. So something that like wherever my mouse is, something like gasoline, something like heating oil, something like propane, jet fuel, which is kerosene primarily, diesel, kerosene you see down here, even paraffin wax, what we think of as a solid, or at least a solid at room temperature, is a crude oil distillate. Liquefied petroleum gas, so liquefied natural gas, essentially. All of these we can get off of it. When we're refining it, we can get stuff like sulfur that is going to settle out down at the bottom. So some impurities that we can refine and use. We can refine this even further and go through a cokeization process and produce coke. We can get some things like petrochemicals off of it. Well, all of these actually are petrochemicals. Anything derived from crude oil is a petrochemical, but stuff like benzene that can be used in industry, we can get off of it. And then many of these hydrocarbons can be used, I mean, not like diesel or jet fuel, but what it's saying as other products and other distillates are going to be used as starting materials to tweak their chemistry and make all of these other things. Everything from plastics, like you see in electronics, shoes, the plastics that are in clothes, like nylon and polyester, the plastics and fiberglass insulation, the the waxes that are on skis, the solvents that are in glue, or these solvents that are just shown as solvents over here, the solvents in ink, the dyes in the ink in many cases, but some of those dyes are going to be based off of certain metals, paints, the solvents, and some of the dyes, stuff like petroleum jelly. So if you are using like Vaseline, that's a petroleum jelly, it's a distillate off of it. Any of these things like insecticides are big, so stuff like DDT, which is an insecticide that we'll talk about later on that is pretty much banned around the world, taken off of crude oil. Fertilizers. It's crazy to think that fertilizers are coming from crude oil, but many of the fertilizers, especially for the Haber-Bosch process, are using crude oil for a heat product and the hydrogens. Synthetic rubbers, so AstroTurf tires coming from crude oil. There is a lot of stuff, and the big one is probably this one that's a little right here, plastics. Plastics represent many of these other things. Okay, so we get lots and lots and lots of stuff off of crude oil. As it says in the bullet point, if it isn't obviously made from a plant, animal, or other mined material, chances are it's coming from crude oil. But since this is the energy unit, let's talk about how we can use it a little bit more in depth. So one is power plants. There are diesel or heavy fuel oil power plants. Those are typically going to be in rather remote, small, and or coastal communities where it is cheaper to bring in diesel than it is to bring in coal or oil, natural gas. Coal or natural gas is cheaper to bring in diesel or heavy fuel oil, especially if they're right on the coast and it's easy to bring in by ship. Many of these local communities are going to supplement variable renewable energy sources with diesel power plants. So when the sun stops shining at night, the diesel generators will kick on. This is a little bit different from many of our types of power plants in the sense that steam is not being used. Instead, they have these banks of giant diesel engines or heavy fuel oil engines, just depending on the plant. And those engines are directly hooked up to a generator. So as the what would it be, like the camshaft in the engine rotates because of the pistons moving up and down, that's going to turn a generator rather than a turbine. So you're going to have a giant engine in there hooked to a generator that's going to generate electricity. Okay. In terms of heavy fuel oil, this is the one that we probably don't think of very much, if at all, in Colorado. You may not even know that it exists. So we think of diesel, we think of gasoline as like our energy sources for vehicles, but heavy fuel oil is used predominantly for shipping. This is one of the thickest of the liquid hydrocarbons that we have, and it is used for fuel. It burns very dirty. It releases lots of particulate matter, lots of soot, black carbon, as you can see on the ship at the bottom right. Nitrous oxides, volatile organic compounds, any impurities like lead or arsenic or mercury that are in that oil, any type of heavy metal that is an impurity in there, all of that will be going into the atmosphere. Shipping is notoriously difficult to regulate in terms of both CO2 emissions and other pollutants because of just the way that the laws are set up. And we do a lot of shipping, which is down on the bottom left with that map. That's global shipping traffic every year. And we have lots and lots and lots of large ships, whether those are cruise ships or more commonly tankers and cargo ships, which are crisscrossing the oceans all the time. The other problem with heavy fuel oil is that it gets into the bilge water of the ship, and many ships will pump that bilge water out directly into the ocean. There's a really good video that I can link on Schoology discussing that, and it's one of those environmental problems that's very difficult to regulate because it happens in the middle of the ocean. In terms of the environmental impact, we're going to focus on oil spills on a later day, but I have two examples of oil spills on the right, one a beach cleanup on the bottom right, and the other that same Keystone Pipeline leak or whatever on the top right. A very famous one that you probably have heard of is the Deepwater Horizon incident. We'll talk about that on another day. So oil spills are definitely an issue, whether that is heavy fuel oil from a ship pumping it out in the bilge or from the bilge, or if it's an accident from drilling or any other operation, a ship that crashes, whatever. We have increased atmospheric CO2. Again, these carbon atoms have not been in atmospheric circulation for hundreds of millions, tens of millions, or millions of years. Really tens of millions. I shouldn't even say millions. So tens of millions or hundreds of millions of years. We have the potential for increased atmospheric methane. So like this crude oil at the top right, this crude oil down here is more than likely degassing methane off of it, and as well as other volatile organic compounds all the time, because methane has a very, very, very low boiling point. and it's like negative 200 degrees Celsius or something ridiculous like that. So it's going to just degas off of oil once it comes to the surface, and whenever it is exposed to the air, it's going to be degassing off of oil. And you have the potential for methane leaks as well as any of those degassing from any of the infrastructure used to transport or refine oil. And then other atmospheric pollutants, including but not limited to these three, as well as heavy metals such as arsenic or lead.